Good morning. Thanks so much for joining me. My name is Simon Brown. This session is about C4 models as code, which is really, of course, about architecture diagrams and documentation. So architecture diagrams have traditionally been horrible. Lots of random boxes and arrows that look like this, and I'm sure we've all seen whiteboards where we've got diagrams exactly like this. This isn't a tooling issue. One of the things I do is I get to fly around and run workshops for teams, and I kind of force them to use pen and paper or whiteboard. And people ask me, if you let people use a tool, do you get better pictures? And the answer is not really. And you can find tons of these diagrams on something like a quick Google search. UML used to be something that we all used to use for diagrams and documentation, certainly those of us who have a little more grey hair than others. But this all faded out in the early to mid 2000s. Predominantly, I think, because of the Agile Manifesto, but also because the UML specification became too complicated to bloated for most people. UML fixes a lot of the issues we typically see with bad architecture diagrams, but nobody wants to use UML these days. Why? Here are all the reasons. I've literally had people say these things to my face. If you use UML here, you'll be seen as old and old-fashioned, which is a bit strange. People think UML is not expected in agile ways of working. They think it's a waste of time, it's too detailed, etc., etc. There is some truth in some of these reasons, but most of them are actually just myths. So I created something called the C4 model, which you can find documented at c4model.com. Quick show of hands, who's using C4 here? So that's a small number. So this should be a nice introduction for those of you who are not using C4 yet. So what I wanted to do was I wanted to create a way to allow teams to draw architecture diagrams in a lightweight but structured manner. That's essentially what C4 is. And this is the underlying principle. If you don't want to use UML or Archimate or SysML or those other formalized notations for drawing architecture diagrams, and you want to stick to boxes and arrows, that's fine, but try to do so in a structured way and make sure your notation is self-describing. So I'm trying to solve a bunch of different problems here that I commonly see with architecture diagrams. The thing that sits behind C4 is a set of hierarchical abstractions. The biggest of these abstractions is what I call a software system. A software system is something like a service that a single team is building, or it's typically something that a single team is building, responsible for. They can see the internal implementation details of. So that's something. That's the thing I'm calling a software system. It's something typically owned by a single team. If we look inside these things I'm calling software systems, I'm going to say they are made up of one or more containers. I don't mean Docker. This has nothing to do with Docker. There's an unfortunate clash of naming. I got the name first, but Docker became way more popular, so that's a bit awkward. By container, I basically mean an application or a data store. So the services and the software systems we build are made up of applications and data stores. So this is your front-end app running in a web browser, React, Angular, etc. It's your server-side apps running on a server, so ASP.NET MVC, Spring Boot, Ruby on Rails, etc., etc. There could be a C# console app or a Windows service. It could be a C++ console app, command line app, that type of thing. And from a data perspective, it's a database schema, something in blob storage, an Amazon S3 bucket, a folder on a file share, etc., etc. So the systems we build are made up of applications and data stores. Collectively, I'm calling these things containers. If we zoom in and look inside the application containers, the things that are ultimately built from code, I'm going to say they are made up of one or more components. So by component, I mean this: a grouping of related functionality, hopefully behind a nice, clean, simple, well-defined interface, running inside a container. So in this set of abstractions, components are not individually deployable units. It's the container. It's the application that's the deployable, runnable unit. And if you zoom into an individual component, I'm going to say they are made up of code-level elements. So imagine you are building a component in C#. When you zoom into that component, it's made up of classes, enums, interfaces. The same in Java, same in C++. In JavaScript, this is now objects and functions. In F# and Haskell, it's functions. So that bottom level represents the code level constructs we have in the languages that we're using. So that's it. It's a set of simple hierarchical abstractions. C4 actually gets its name from the diagrams, the diagram types. And in this case, the static structure diagram types. So C4 stands for context, containers, components, and code. So it's 4 levels of diagrams that map onto the 4 levels of abstraction. And what we're doing is we're starting with a bunch of high-level boxes. We're zooming into a box to show the internals of that box. We're then choosing another box to show the internals of that box, and so on and so forth, right down to the code level if you want to. Although C4 has the number 4 in the name, I don't recommend using all 4 levels. The 4 levels are there for completeness. Most teams only use the top 2 levels, the context and the container diagram. And the concept here is diagrams as maps. So I live in Jersey in the Channel Islands. If you open up Google Maps on your phone and you do a search for Jersey, you're probably going to get that picture there. So this is great if you want to know where the airport is in Jersey and where the nice beaches are and where the roads are. If you've never heard of Jersey before, it's too much detail too quickly. How do you fix this problem with Google Maps? You pinch to zoom out to get some more context. If you zoom in further and zoom in and zoom in, eventually you drop down to Google Street View, which is a one-to-one mapping with the real world when the photos were taken. I want to do the same thing with architecture diagrams. I want us to have a collection of hierarchical architecture diagrams that allow us to tell different levels of detail, different stories to different audiences. Think about the last time you joined an existing project and they had like 500,000 lines of code and they just dump you in the code base and say, hey, add this feature, please. That's too much detail too quickly. You need to zoom out to try and figure out what it is we're building here, where it sits in the rest of the environment. So yeah, diagrams as maps is a nice analogy here. I'm going to focus on the top 2 levels of diagrams before we get into the tooling side of this talk, because it kind of helps set the scene for what we're going to discuss later. So the top level diagram of C4 is a system context diagram. In order to draw a system context diagram, you need to answer these basic questions. So what is the thing we're building? What is the scope of the thing we're building? What features sit inside the thing we're building? And what features sit outside the thing we're building? Who is using the thing we are building, the system or the service? And how does it fit into the world around it? In other words, what are the system integration points, the service-to-service integration points? Answer those questions, and you can draw something like a system context diagram. So this is a real example diagram from one of the workshops I ran. The group here have correctly identified this red box is the financial risk system that the group were designing. So this was an upfront design exercise. They have correctly identified 2 types of users, and they have correctly identified the external systems in the organization that we need to have an integration point with. So that's an example of a system context diagram. It's showing you the system we're building or describing or documenting or designing and things around it. But of course, as developers and architects, we want more detail. So how do we do that? We can drop down to level 2, and we can draw a container diagram. To draw a container diagram, it's a different set of questions because now we're looking at a different level of detail. So what are the major technology building blocks? What are the applications and the data stores that make up this system? What are their responsibilities and how do they communicate? Answer those questions, and you can come up with a diagram like this. So you'll notice the red box is now a lot bigger. So now we're zoomed into the inside of that financial risk system red box, and we're showing the applications and the data stores that make up that system. So here we have a couple of Java Spring server-side things. There's a couple of React front-end web apps, some data stores, etc., etc. One thing I want you to notice, because we're going to talk about this later, if I go back a second, this is the context diagram. You'll notice there are 2 users and 5 software systems. When we zoom into the container diagram, we should hopefully see 2 users and 5 software systems. There's one missing here, but never mind. Which one's missing? The monitoring system as usual, probably. So we're repeating elements across our diagrams. And that's something that is going to be important to focus on later. C4 is notation dependent. A lot of people on the internet seem to think that C4 is blue and gray boxes. That's not the case. So you can use any shapes, any colors. That's entirely up to you. And you could also use UML if you want to. So C4 is just a set of abstractions and a set of diagram types. Whatever notation you want to use is entirely up to you, and that's all fine by me. So tooling. When it comes to tooling, I've tried to assemble a list of all of the tools that provide some degree of specific support for C4 on the c4model.com website. So click the link, it takes you down. Some of these are diagramming tools, some are modeling tools, some are commercial, some are open source, and there's a bunch of tick box filters that you can use to try and find some tools you might want to evaluate. Most teams generally use these types of tools. Who's using these types of tools for drawing diagrams, architecture diagrams? Yeah, this is going to be a big number of people. So this is your Visio, Lucidchart, Draw.io, Diagrams.net, Confluence, and Glyphy style tools. These are general purpose diagramming tools. You open a blank canvas, a blank document, and you start adding boxes and arrows. These are fantastic tools. They're very sophisticated tools, and I love them, but I do not recommend them for drawing software architecture diagrams, especially if you're going to use C4. Why am I saying this? Number one, a general purpose diagramming tool can't help you. So you open up a blank diagram and you're going to draw a system context diagram. So you add a couple of boxes and then you decide to add a component to your system context diagram. There are not many rules in C4, but one of the rules is don't have components on a system context diagram. A system context diagram should really only include people and software systems. So we've broken one of the rules of C4 here, and the diagramming tool can't tell you that you've done that because it doesn't know what you're doing. All it sees is boxes and arrows of different colors. So there's no rules, there's no guidance, there's no semantics. Number two, there's no consistency. The responsibility is on your shoulders to provide consistency across all of your diagrams. So you sketch up your context diagram on the left, and then you open up a new tab, a new diagram, a new canvas, and you start to sketch out your container diagram. And then you decide you want to rename something. So here you'll notice the names don't match. Remember when I showed you the example drawings? We repeated the users and the software systems. You have to do that with C4. Which one of these two names is correct? See, now we've got an inconsistency. We have to go back and make sure everything matches. This is fine if you only have 2 diagrams. If you now have 20 diagrams, this gets much more complicated much more quickly. We like using Git and source code control tools. We like putting these diagrams in source code control so we can have easy access to them and version control them and pull request them, etc., etc. If you try and dump out many of these diagramming tools to text-based formats, you often get a horrible big base64 encoded string or an XML file. These things tend to mix up the content and the presentation. So if you have an architecture diagram and you change the color of one box, you'll get a completely different file, which is kind of annoying. It makes your diff absolutely gigantic. If you can diff it, of course. So this mixing of content and presentation makes diffs really hard to do. You can't automate many of these tools. Imagine you have an AWS or an Azure environment. It's very hard to point some tooling at these environments to reverse engineer a diagram and create that automatically in a tool like Visio. There are ways to do it, but it's not particularly straightforward. These tools are very hard to integrate into CI/CD and build pipelines. And these tools are a pain in the ass. Right, this is my biggest problem with these tools. You spend far too long lining boxes up. You'll notice that arrow looks straight. It's not, it's 1 pixel out. And we've all been there and we've all done it. You have to start nudging elements around the canvas. And then you get the text in the top box, which just fits, but maybe we should make the text smaller. But now should we make the text smaller in all boxes or just that one box? Right, we shouldn't have to be dealing with these sorts of silly issues. So back in October 2020, that time that some of us would maybe rather forget, the ThoughtWorks Tech Radar blipped diagrams as code as a thing they recommend that you trial. Diagrams as code is basically, instead of using a UI to draw some pictures, you write some text, some DSL, some code, and the tooling creates diagrams for you. The most popular and frequently seen tools are PlantUML and Mermaid. Diagrams as code is great because as developers, we like text. We have tons of tooling to support text, IDEs, VS Code, etc., etc. It's easy to author. We can automate these things because many of these tools are command line driven. The text files are text, so they fit in source code control nicely. They're easy to diff. There's lots of good automation opportunities with these types of tools. There's something called C4 PlantUML. So PlantUML is a generic kind of UML-based tool for drawing UML-style diagrams. C4 PlantUML is essentially a set of macros that sits on top of PlantUML and allows you to describe C4 concepts using terms like person and software system. So it kind of elevates you into a much more C4-style domain-specific language. So that's quite nice. That's what a lot of people start with when they want to draw C4 diagrams with the diagrams as code tool. The problem with these tools is that they are still diagramming tools. If you want to create 2 diagrams, you have to create 2 text files. If you want to rename an element, you have to rename it in both text files. There are ways you can do include, so you can include a common set of elements in multiple text files. And as developers, we do have VS Code, and we can use global search or replace. So some of these problems are solvable, but fundamentally, if you want 2 diagrams, you have to create 2 text files. We're using PlantUML and Mermaid as an input format here. I want to change how we do this as an industry, and I want us to move away from diagramming and back to modeling. Now, when I say modeling, lots of old people in the room get scared because we've all seen this. You know, back in the early 2000s, late 90s, rational rows. Who's used rational rows here? Anybody? Yellow boxes with a purple or pink border. That looked absolutely horrible. So rational rows is a very big, very expensive, very bloated tool. We used to spend months and months and months plowing all of the information into these tools to get some wonderful looking diagrams, and then the project gets cancelled. There's lots of bad associations around modeling and modeling tools, and that's why many teams have thrown all of this modeling stuff away, and they've really gone back to drawing sketches on a whiteboard. That's led us to the problem we have today, where those sketches are completely incomprehensible. So I'm a big fan of modeling, but I don't necessarily want to take us back to rational rows. I want to do something a little bit different. So during the pandemic, so the way I earn most of my living is I fly around the world and teach people how to do software architecture diagrams. It turns out you can't do that when you're not allowed to leave your island that you live on. So I had not much to do, and I built some tooling called the Structurizr DSL. Everything I'm going to show you is all open source. It's all available on GitHub. The Structurizr DSL is an open source text-based domain-specific language that I designed specifically for crafting up C4 architecture diagrams. I like to call this diagrams as code 2. So if you want to create 2 diagrams, what you do is you create a single file and have the tooling spit out and create and automatically generate multiple diagrams. This is the concept of modeling. The concept of a model is fairly straightforward. You create yourself a single dictionary of all of your elements and relationships, and then you reuse them across your diagrams. If you want to rename an element, you rename it in your model, in your dictionary, have your tooling regenerate your pictures, and everything is now completely in sync. That's the power of a model. Why is this useful? Many people start out with C4 PlantUML. They create a bunch of text files in PlantUML format, and that works for small projects or small code bases. And then over time, they add more. They want to model more systems in their environment, in their group, in their department, and they start to get inconsistencies between all these different diagrams. And I've seen this. I've seen many teams move from tools like PlantUML and Mermaid to the Structurizr DSL because it fixes the inconsistency problems, which means you can now start to do things like enterprise-wide modeling of all of your software systems, for example. So really, this is models as code, as opposed to diagrams as code. And I guess more accurately, this is really just focusing on C4 models as code. There's one concept I'm going to talk to you about before we dive into a tooling demo, and that's called a workspace. A workspace is nothing more than a wrapper for a model, which is a set of elements and relationships. A set of views, the views get rendered to diagrams, and some supplementary documentation if you want it. So, enough of the slides. Let's jump into a demo. I have Docker running here, and in addition to the Structurizr DSL, I built some tooling called Structurizr Lite. Structurizr Lite is a Java Spring Boot application, half server-side, half client-side in JavaScript, and essentially it's a rendering engine for these diagrams. So what I'm going to do, here's my desktop, which is currently empty. I'm going to start up Structurizr Lite. Let me show you the script first. This is just booting up a Docker image, doing a port map, and doing a volume mount. So I'm going to start up Structurizr Lite against a folder on my desktop which doesn't yet exist called NDC. So I'm going to start that up. Here you go, Structurizr Lite. This is available on Docker Hub. It's also available as a Spring Boot WAR file if you want to run it that way. So now Structurizr Lite is running. We can go to Chrome, go to localhost 8080, and we have a diagram. So where did this diagram come from? So what we have here on our desktop is now that NDC folder, and inside of the NDC folder is a file called workspace.dsl. This is the Structurizr DSL. So here's our workspace, our model, and the set of views. We are defining a person with the name user and assigning that to an identifier called user. We're defining a software system with the name software system and assigning that to an identifier called software system, just to be confusing. And we're creating a link, a relationship between the user and the software system with a description of users. We're defining a system context view for the software system. That's just a diagram identifier. And we're saying include star. What include star does here is it says include that software system and include anything pointing to it or pointing from it. So this little bit of text gives us this diagram here. One thing you'll notice with many of the PlantUML, Mermaid style tools is they are all automatic layout. Automatic layout, I think, works okay for small diagrams. I don't like it. I don't like automatic layout because when I'm drawing a software architecture diagram, I want to put boxes in a specific place. I want a nice flow from left to right or top to bottom. I want my web apps at the top and my databases at the bottom. And sometimes automatic layout doesn't necessarily do that in the way I want it to. So this Structurizr Lite tooling by default is a manual layout tool. So what we can do now is we can start moving boxes around. We can change the canvas size. We can introduce line breaks. We can change the routing of things. This will save. We can go back to the DSL. We can now change the name of something. So let's call that business user. Save it, go back, refresh. And there's a merging algorithm built into this tooling that tries to figure out what you just changed and replaces it on the diagram accordingly. Now, some of you might be thinking, well, where are these box coordinates stored? Because it's not in the DSL file. And you're absolutely correct. There's a JSON file here. And the JSON file contains the full kind of breakdown of that workspace definition. So here we have our model and our people, and here's our business user, a bunch more stuff. Here's our software system, and here's the view with all of the XY coordinates. So what you can now do is you can take this folder, check these two files in source code control, and now anybody on your team can boot up this Structurizr Lite Docker container with that folder and see exactly the same diagrams. So that's generally how I prefer to use this tooling. It's a manual layout-based tooling. For the purposes of the rest of this demo, I'm going to switch to automatic layout because it makes it a little bit quicker. You can do that by saying automatic layout, left, right, we'll go. So here we have an automatic layout version of that same diagram. So let's imagine now that we have crafted our context diagram, and we're happy with this, and we want to now draw a container diagram for this same software system. How do we do that? We go into here, we add a set of curly braces, and now we start defining the containers that sit inside that software system. We'll wait for that to go past. So let's define a web application, and that's going to be a C4 model container. We'll just call it web application. Let's define a database. We'll give that a name database. And let's say that the user has a link to the web application with a description of users. And the web app has a link to the database with a description of reads from and writes to. So if I save this and go back here and refresh, what's going to happen? Any ideas? Nothing. So I've added element into my model, but I've not created a view to visualize those elements. So what we need to do is we need to create a C4 container diagram. How do we do that? What we do is copy paste this block. We change this, so we want a container view for the software system. We'll need to change this diagram identifier. Include start is now going to do something different. Include start is going to say include all of the containers inside that software system and everything linked to it. And we're going to apply automatic layout once again. So now if I save that, go back here, refresh, you'll notice there's a little magnifying glass here. Now we can double click and we drop down to level 2 and we see the container diagram for that software system. So we have the user using the web application, which is reading from and writing to the database. We can start to now add more description onto this diagram if we want to. So we can say description stores interesting data, and that will show up on the diagram there. And we can start to add technology choices and things like that as well. So we can say technology MySQL, and that has appeared just there as well. So something I want to point out with all of this, because we're really talking about the concept of modeling here. One of the concepts we always talk about in software development, in coding, is do not repeat yourself. Dry. But I've done exactly that. So I have a link user to the software system with a description of users, and pretty much the same relationship between the user and the web application. So I've had to repeat myself, and I don't want to do that, because I want to make this simpler for me to change the names of these descriptions in the future if I want to. How do I fix this problem? The answer is delete that one. So now in this text file, we are defining two relationships, user to the web app to the database. So if I save this, go back to my container diagram, refresh, these are the two arrows we've just defined in the text file. If I go back to my context diagram, this arrow is still here. So this is a feature of this tooling called implied relationships. Because there is a relationship between the user and the web application, and the web application sits inside the software system, there is an implicit or an implied link between the user and the software system itself. And the tooling kind of works it out and adds it for you. You can customize this. You can add your own strategies for doing this, your own algorithms, or you can disable it entirely. So there's a whole bunch of ways you can do this. Just as a point to note, the tooling that sits underneath this DSL is basically an open source Java library. And there are ways to go from the DSL into that open source Java library. So you have complete control over everything that sits underneath this as well. So that's a kind of quick demo on the concept of modeling, creating a context diagram, adding some containers, et cetera, et cetera. We need to make this diagram look pretty. Like a bunch of gray boxes is not exciting at all, and most people do not want to put diagrams like this in their documentation. So how do we change the color and styles of these things? If any of you have done front-end development, so you draft up a bunch of HTML elements and you add CSS tags and you apply styles via tags, CSS classes, this is the same type of thing. So I can enable tooltips here, and if I hover the mouse over, you'll see that this business user, this person element, has an element tag and a person tag. The software system has an element tag and a software system tag. And containers have an elements tag and a container tag. So there are a predefined set of tags that get associated with these elements. And what we want to do is we want to basically add styles for these tags to change the look and feel of these diagrams. We're essentially separating content from presentation. So what we can do now is we can go down here and we can add a styles block, and we can say add an element style for the element tag. The background is going to be, let's go orange. So this changes all of the elements to orange. So we've applied that style to the element tag, which kind of hits everything. If we only want to change the shape of the person, we can essentially do the same thing. We can create an element style for the person tag. Background orange, red I think is a color, and shape person. So now we've basically changed the color of all people. So if you have a nice kind of corporate color scheme, you can just write yourself a bunch of styles and have this applied to all of your diagrams super simply. Or you can disable it and override it, of course. So that we've got our context diagram. We can double click in here. I want to change this database shape to a cylinder. If I look at the tags, element and container, element and container. What I need to do is I need to add a tag for the database element and then add an element style for that database tag. So let's do that here. We go back to our database definition, tags, database, save, refresh, tooltips. So now we have a database tag sitting on that element. And now what we can do is we can go element style for the database tag, shape cylinder. So now we have a database shape. One of the things I said during the little presentation part is if you're going to use boxes and arrows, make sure you do so with structure in mind. So the C4 model gives you structure, but what about the self-describing notation part? I've got a bunch of orange boxes. Well, it turns out that this diagramming rendering engine generates you a diagram key automatically. So it looks at what the element tags are and the styles and kind of pulls all this information together and generates you a diagram key automatically. So this is another thing that this kind of tooling takes away from your hands, which is quite nice. What else can we do with this? We can add things like icons if we want to. So I have an icon here for Spring Boot. Let's copy that into this folder. Let's go to the web application and say tags Spring Boot. We can go down here, create an element style for the Spring Boot tag, icon, Spring boot.bot, boot.png. Now we have a rather horrible green logo on an orange background, so that might not look very nice, but that's also included in the diagram key now. So every time you apply that Spring Boot tag, you get that exact same styling. So that's the basics of the Structurizr renderer. Something I want to point out is that this is one rendering tool. The Structurizr DSL, this thing here, is rendering tool independent. So you can actually render this same diagram with many, many tools. So what I'm going to do here is I'm going to take out the icon. For a reason I'll explain in a second. I'm going to copy this file into my clipboard. I'm going to go to, so at structurizr.com/DSL there is a demo page I've set up. It has a text editor on the left hand side and a diagram on the right hand side. I'm going to paste in this example here, go render. So this is going to give us the same example we just had locally with Structurizr Lite. So this is a nice way to try the tooling out if you want to try it out without installing anything. So this is the Structurizr Lite renderer, essentially now hosted on the Structurizr cloud service. Also on GitHub is there's a Structurizr export library. This is a bunch of Java code that basically takes those view definitions from the DSL file and converts them to something like PlantUML. And I've embedded those exporters, that export library, into this demo page on the website. So if we get rid of that. So here is the PlantUML definition of the container diagram, which I can render in the browser. And there's the diagram key. So here you have an alternative visualization of that exact same diagram now using the PlantUML tooling. And the context diagram will be similar. Something you'll notice is different tools look and feel different. So what I've done is I've tried to replicate the look and feel of the Structurizr rendering engine in some of these other diagrams as code tools. It gets close, but not always exactly the same. So there's an export to PlantUML. There's an export to C4 PlantUML. C4 PlantUML comes with its own blue and gray styling. So that's what you'll get by default. But it is possible to override that. So if I go here, I can say properties C4 PlantUML.tags true. Go render. And this should look orange now. Yeah. So this is now a C4 PlantUML export with those styles from the workspace. So when you're crafting up PlantUML and Mermaid diagrams by hand, you're using PlantUML and Mermaid as an input format. This tooling is using it as an output format. So that's one of the reasons this is rendering tool independent. There's an export for Mermaid. So Mermaid is picking up in popularity because it's now supported on GitHub. You can render these things natively in readme.md files, for example. So that's the container diagram. This is the context diagram. There's an export for the dot format for use with tools like Graphiz. And if you have dynamic diagrams, you can export those to web sequence diagrams format as well. So there's a bunch of stuff you can do here, and this is all open source, this is all Java. You can write your own exporters to export to other diagrams as code type formats if you want to. If you really want to, you could potentially export the DSL to something like Visio. Now, I'm not suggesting you do that, but it is something that you could do if you really wanted to. So that's a quick demo of the kind of basics of the Structurizr rendering engine, crafting up a model, and exporting it to different formats. On that note, if you want to export these formats from something like a CI/CD build process, let me shut down Structurizr Lite. There's something called the Structurizr CLI, just like a command line interface tool for this, this stuff, which I have installed here. And you can say export. The workspace is user Simon, desktop NDC, workspace.dsl, format, PlantUML. So that will generate me a bunch of PlantUML files in that folder. So again, you can have people check this DSL file in, and then your CI/CD build process can generate you a bunch of PlantUML files, which you then stick in source code control or do whatever you want with. In terms of the DSL itself, once you start getting larger DSL files, you might think, how do I split this up? There's a way to include fragments, so you can draft up a bunch of components or containers in a separate file and include it into your main file. And there's also a workspace extension feature. So what you can do with the workspace extension feature is you can have a single workspace that defines all of your software systems, and then you can have every individual team extend that workspace and add their C4 model drill down diagrams for their specific system. If anyone here is using tools like Backstage, Spotify's Backstage tool, or like a service catalog, it's the same type of approach. You define your service catalog, your system catalog, and then you have individual workspaces extending that service catalog to fill in the implementation details. So something I see a lot of teams doing is they want an enterprise-wide view of their software systems, but they want teams to own the individual documentation for those software systems. So that use case is also supported by this tooling. There's also some other nice things you can do with this tooling. Let me boot up Structurizr Lite again. If I go back to this diagram, so you'll notice on this diagram, we've lost the Spring Boot icon. We'll bring that back in a second, but this container doesn't have any technology choices like MySQL does. So let's add a technology description here of Spring Boot. If I can type properly. So that's going to now add Spring Boot into my diagram. And if I bring back that element star for the Spring Boot tag, let's go background green. Again, duplication. So I've mentioned Spring Boot twice here, which is kind of annoying. It would be really nice if we could just set the technology to Spring Boot and have a tag kind of automatically associated with that technology choice. And that's something you can do. So what I'll do now is I'll delete that tag. So I'll go back here and refresh. So now we've lost the Spring Boot tag. We're just back to element and container. The DSL actually supports a bunch of scripting languages that are supported by the underlying JVM. If you want to go to the documentation for all of this stuff, you can go to docs.structurizr.com. Again, this is all open source as well. If you see any errors, please raise a pull request. If we go to the DSL, there's a cookbook. And the cookbook has a bunch of like recipes for doing common things. And one of those common things you can do is scripting. So scripting is supported with languages like Groovy, Kotlin, or JRuby. And I can write a short script that basically converts the technology to tags. So what I'll do, I'll copy that to my clipboard. I'll put this underneath here. So what the script is doing is it's getting the model from the workspace, looping through all of the elements. It's finding the elements that are an instance of the C4 model container, and it's basically saying add a tag with the value of the technology field. So now if we save that, oops, and go back here and refresh, we should go green again. There we go. So now this thing has a Spring Boot tag that we've only defined once in the technology property of that element. So there's a whole bunch of stuff you can do once you get under the covers of the DSL to the underlying Java library. You can add, remove relationships and do all sorts of fancy stuff. So that's, again, basic example. Let's shut down Structurizr Lite. If you go to the c4model.com website, you'll notice there are a bunch of example diagrams for an internet banking system. I don't want that one, I want this one. So I'm going to boot up Structurizr Lite against that set of diagrams, that workspace. Open up the tab. Yep. So here are the example diagrams. So we have our system landscape diagram. Double-click, get to the system context diagram. Double-click, get to the container diagram. These are the same examples you'll see on c4model.com. Double-click, get to a component diagram. Double-click, we have an image of a class diagram here. So level 4, the code level, is not supported natively by the Structurizr DSL tooling, but you can add in an image file or a PlantUML definition or a Mermaid definition. We also have a dynamic diagram here. So this is interactive. It's showing you how the sign-in feature works in this particular example. You can export this to web sequence diagrams if you want to. And things like deployments diagrams are also supported. So this is showing a deployment environment, and this is showing a live deployment environment. So those are the diagrams rendered in the Structurizr Lite tooling. The reason I've shown you this is because there's another tool called the Structurizr Site Generator, which is, again, open source, nothing to do with me. But it takes that same workspace definition. It's in this case, it's just another Docker image I'm booting up. And it gives you an alternative way to visualize the data that's stored in that workspace. So this is the Structurizr Site Generator. We can go software systems, we can click on internet banking system. And what it's doing is it basically built us a little static website here, which gives us a view onto that model. And we can start clicking around. So here's a context view for the internet banking system. This is using the PlantUML exporters, in this case, the C4 PlantUML exporters. And what the people behind this tool have done is they've hyperlinked the diagrams together. So you have here a set of hierarchical but navigatable diagrams based upon PlantUML in your web browser. And it shows you deployment views, and you can click dependencies and start kind of hunting around the model to kind of see different relationships and what's going on. So that's another interesting tool. It's another interesting way to visualize essentially the same information. So that's Structurizr Site Generator. You'll find a link to that from the Structurizr documentation. One of the big questions I always get with all this tooling is, well, hang on a second. All of your example diagrams have been like 4, 5, 6, 7, 8 boxes, and they all look quite neat. How do we make this work for bigger systems? So what I'm going to do now is I'm going to boot up Structurizr Lite against a kind of service, a microservice-based example. So imagine we have some sort of a service-based architecture. So we have a web application that has a connection to service 1, where service 1 in this case is an API talking to some sort of a database schema. And then maybe that has a link to this thing over here, which is service 2, some sort of API and a database. So we have some sort of a service-based architecture. And every service is an API and an individual owned data store. And I've associated different colors with every different service. This example looks okay. We've only got like 16, 17 boxes on here, but as you add new services, this diagram would start to get much more complicated, wouldn't it? So how do we fix that problem? This diagram is showing you all of the services. It's one diagram showing you all of the services. What you can do instead is draw one diagram per service. So here we have a container diagram that's just focused on the service 1 thing, things coming into service 1 and things leaving service 1. Here's service 2, same thing, inbound relationships, outbound relationships, and here's service 3. So we have different views of essentially the same data, the same model here. How do we do that? We go to here, I can show you the source code for this thing, services. So this is the same thing, we're creating a workspace with a model. Here's our software system. This is the definition of service 1. So service 1 is a group of an API container and a database container. Service 2 is the same thing, service 3 is the same thing, etc., etc. Bunch of arrows between them. Someone's stuck in traffic. This is the all containers version. So this is saying include all containers for that software system. This is the service 1 version. So what we're saying here is include software system.service1, include things coming into that thing and things coming out of that thing. So the inbound and outbound relationships, the afferent and efferent couplings, if you want to use that terminology, and apply automatic layout. Same with service 2, same with service 3. So this is a way to basically give you a bunch of different views onto that same underlying model, which is really nice because, of course, in tools like Visio, what you do is you craft up your big diagram, and then you have to start copy-pasting elements across multiple different worksheets and things. And you start to get that inconsistency problem. So this is another approach. There's a bunch of expressions that are built into the Structurizr tooling that allow you to slice and dice your model in various different ways. So I've mostly been using include star, but you can include things by name, include things by reference, include things by tag. You can use this sort of expression which says include the thing and inbound relationships, etc., etc. So there's a whole kind of complicated expression language that's built into this tooling as well. So that's option 1. I like giving people options. This is option 1 for dealing with large and complicated software systems. We have a diagram with everything, and we have multiple diagrams showing one service. Option 2 is in Structurizr Lite, which is all free, it's all open source. You click this Explore button, and you get this. So this is a D3JS force-directed graph. It's showing you exactly the same information. This is showing you all of the containers inside that software system and the links between them, but it's showing you in a much more succinct, concise data, in a much more concise visualization format. It's interactive, there are tooltips, we can hover over relationships and things, we can start clicking things to show nearest neighbors, and there's a quick find feature. So this is another really nice way to kind of explore and visualize larger models. Especially useful for portfolios of systems across an enterprise, or maybe if you have a complicated distributed architecture, or maybe have a large number of components inside a monolithic application. This type of visualization suits larger data sets. So that's option 2. I'm going to give you another option. There is another export format, let me shut this one down, that the Structurizr CLI supports, and it's called Ilograph or Ilograph. So we're going to export the workspace we just looked at, and the format's going to be Ilograph. That's going to create me, what have I done? I know what I've done. That's going to create me this file, a .idl file. So this is the Ilograph format, which is YAML. I don't know how you feel about YAML. I'm not a big fan, so I wouldn't necessarily recommend crafting this by hand. But what I'm going to do is I'm going to copy this into my clipboard. I'm going to go here and open up app.ilograph.com, which is this one. I'm going to click New Diagram. I'm going to take out their example, paste mine in, minimize. See, it's horrible, isn't it? We'll get rid of that. We'll get rid of that, and we'll click Static Structure. So this is another alternative visualization of that exact same data. We have our web application calling services and database, etc. And you'll see as I move the mouse around, things hover, and we can also click and zoom. So it's a nice interactive visualization. So this is another great tool for exploring kind of larger data sets, hierarchical data sets, and of course the C4 model is essentially a force-directed graph of hierarchical elements and the relationships between them. So that's something else that you can do here. And that's really all I wanted to show you with regards to the Structurizr tooling. Is there's tons more stuff you can do. It supports documentation and architecture decision records, and there's an on-premises version which is free and open source, and you can embed in Confluence and tons of stuff like that. But that's kind of the basics of the Structurizr DSL tooling and some of the different rendering engines and possibilities. Just to finish up a couple of slides. The concept we've been looking at here is the workspace. The workspace is the wrapper for the models and views. There's actually a number of ways you can author those workspaces. I've shown you the Structurizr DSL. There are also a bunch of code-based libraries. There's a Structurizr for Java, there's a Structurizr for .NET that allow you to craft up some code and basically get to that same workspace format. And then you can render those workspaces with a number of tools as I've been showing you throughout the demos. So that's my Structurizr tooling and the kind of ecosystem around the Structurizr tooling. And again, everything I've shown you is all completely free, completely open source. To make this a balanced discussion, I do want to throw out some other options out there, because over the past couple of years specifically, some people on GitHub have been creating similar types of tooling that gives you similar types of capabilities. So there's something called Overarch, which allows you to do the same type of thing. It allows you to define a hierarchical C4 model and get a bunch of views off that model. But this is using something called the extensible or extensive data notation, EDN. So this is a slightly different way to craft up those diagrams. I think this tool uses PlantUML as a rendering engine, so automatic layout only. But that's another tool you might want to look at. There's something called RDB modeling, which is a YAML file and an editor. So you kind of type in some YAML on one side and you get a diagram on the other side, and again allows you to create a model and surface different views of that same model. So that's something you can look at too. If you like PlantUML, somebody has tried to create a way to build a model-based approach to using PlantUML. It's a bit complicated. I'm not sure I really understand what they're doing with the underlying kind of tech here. But if you're into PlantUML now, and specifically C4 PlantUML, this allows you to start exposing some of those things as elements you can reuse in other definitions. So that might be something to look at. Somebody created something called like C4 recently, which I thought was quite funny. What they've done is they've taken my Structurizr DSL and kind of copied it. But the big difference between like C4 and my Structurizr tooling is that in like C4, you can have any number of hierarchical abstractions. So in C4, there are 4: software systems, containers, components, and code. One of the criticisms I hear of C4 is we don't want to be pigeonholed into only those 4 levels of abstraction. It would be nice if we could define more levels of abstraction, like a group or a service or a library or a module, something like that. There are a number of reasons I don't recommend doing that. I have another talk you can find online. It's called The Myths of the C4 Model. If you do want to do that, like C4 allows you to define additional levels of hierarchical abstraction. So it kind of takes the Structurizr DSL and removes some of the restrictions around the levels of hierarchy. So again, something to look at if you're interested. Illograph, I've talked about already. The input format for this tool is a rather long YAML syntax. If you do use this tool, the editor thing does do autocomplete, so that does help you to some degree. But again, I built an exporter that takes the Structurizr DSL and converts it to that YAML format, so maybe that's a better approach. And that's it. So I hope you found that useful. If you do want to get started, just go to structurizr.com/DSL, you get that demo page, and this is a nice lightweight way to get started without installing any tooling. Thank you very much, and enjoy your lunch.